All right, boys and girls, we are going to do our first lesson of our at-home learning, and it is going to be over set theory and Venn diagrams. So set theory, a set is merely a collection of elements, numbers, color, or people one day we'll get there. So a collection of elements, not like chemistry elements, but elements as in numbers, colors, people, etc., etc. Colors, people, and then the old etc. dot dot dot. So some examples we may see of a set would be, notice we used a bracket, would be red, orange, green, and yellow. So those are all colors that would be included in a set. So a universal set is a set that has all possible elements. So it's a set with all possible elements. So whatever's included in the study, that will be included in the universal set. So for example, if I had my universal set, notice bracket, 0, 1, 2, 3, 4, and 5, those are all in the universal set, meaning everybody. And then a subset is just something that can be with those numbers above, but it's its own thing. So set with elements from the universal set. So if I'm using the universal set above, I could say 0, 3, 4, and 5 could make up a subset. Another example, so something you guys would use, is let's say we're looking at geometry class. So our universal set is going to equal geometry class. This class involves all of you. So first period through fifth period, all 70 students. If I was making a subset, okay, if I were going to make subsets, I can make subsets of, so it could be, the first subset would be students who play baseball that are in geometry class. Students who play lax that are in geometry class. Students who play soccer that are in geometry class. So all 70 students would be in my universal set, but I couldn't take up my baseball, so I'm going to forget somebody, so I apologize. But say we got Daniel and Darren. Okay, those are baseball players in my subset that make up my universal set. Some lax players would be Graylin and Harrison. Those are in my universal set and they play lax. And then soccer would be Kate and Dylan. Again, I'm sure I forgot somebody, but I'll use two of each one, so don't get too mad at me. So it is, the universal set would be geometry students. And then I could break it down into baseball, lax, and soccer. I could break it down into track if I wanted. And they would be in subsets of my 70 geometry students. Relationships of sets. So we have intersections, elements that have two sets in common. Okay? Elements that have two sets in common. Now, this is going to be fun because we're going to think of this as if we're thinking in and. Our word for intersection is going to be and. And it gets a symbol of an upside down N. So when we think of intersection, we get the word and. That means it's in one and the other. So if you look at C and D, for our example, we want to know who is in both subset C and subset D. Well, we look at our subset. Subset C has 7 and 8. Subset D has 7 and 11. What number is in C and in D? Well, 7 is in both. So to have a subset of it, we're going, it's just the number 7. The next one we're going to come across is a union. Elements from both sets. We are not going to repeat. So if they show up twice, we're just going to write them once. So text, a union are elements from both sets. And remember, remember, these are not going to repeat. Thank you for putting that in there. So think of a union as or. They're in one or the other. So or, our word of the day is or, one or the other, and this one is a U. So when we look at C and we look at set D, we've got C or D. So what one is in both? So I've got 7, 8, and 7 and 11. So we're only going to write each one once. So 7, 8, and 11 is in C or in D. The last one we're going to come across is a complement. Complement is elements from the universal set that are not in any set. So we're talking about stuff that's in the universal set, but not necessarily in the subset. So if we think back to what we did earlier with geometry students, these are students that are in geometry, but they don't necessarily play a sport. So they would still be included in our universal set, but they couldn't fall into any of the 3 subsets I listed. Or it could be a track student like Brooke. So complement is elements from the universal set that are not, emphasis on the not, in that set. So we think of a complement as not. So our word is going to be not. Symbol for a complement is A prime, or you'll see A bar. So complement is A prime or A bar. When we look at our universal set, we've got the numbers, it looks like, for universal is 0 through 9. And then for set A, we have 2, 5, 7, 8, and 9. We want a complement or a bar who is not in A, but is in our universal set. So we look at 0. Is 0 in the universal set? Yes, so it's right here. Is 0 in A? No, so that would be a complement. Is 1, 3, 4, and 6. So all of those numbers are in my universal set, but not in set A. So we got our A prime or A bar, either one. Okay. That concludes page 1. Continue watching for page 2.